Hello students and welcome to another lecture about chemical bonding. Today we're going to be looking at covalent bond. A covalent bond, it's when I have two or more electrons that are shared. Of course, it depends on how many covalent bonds, but one covalent bond is made of two shared electrons. A covalent compound is the compound that contains only covalent bonds. So why do atoms or should atoms share electrons? Why don't they all just lose and gain like we've seen in ionic bonding? Now, if a fluorine is to bond with another fluorine, right, it's not like there is no way I can convince one fluorine to lose an electron so the other one can share it, because sharing an electron, so the other one can gain it, because gaining an electron will make it go to the octet, will make it look like neon, but that will make the other fluorine have 6 electrons, which is really bad. So in this case, there is a compromise because the power is equal. They both want to gain an electron, right? So in this case, what happens that I'm going to color code that for you, that this fluorine here will give this electron. I'm going to make this red, and this one here is red as well, okay? So these two reds right now are being shared. One came from the fluorine on the left, and the other one came from the fluorine on the right. Now, each one of them, that's the beauty of it, because these two electrons are shared, each fluorine can pretend that it has 8 around it, and each one of them feels stable and looking like neon. All right, so they achieve the stability of a noble gas configuration by sharing electrons. Those electrons that were black, that ones that were not red, those electrons are the ones that we call lone pairs. They are non-bonding electrons, okay? So they did not at all participate in the bonding because they were not shared. And each fluorine will have its own separately, right? Not shared. The ones in the middle, the ones that let's color code again. So the ones here that were red, those are bonding pair or a bond, a covalent bond. Every covalent bond is made of two shared electrons. For this fluorine, these are the lone pairs on the fluorines on the right. They only belong to that fluorine, and we call them lone pairs. They are non-bonding electrons. And the other fluorine, these are the ones that are lone pairs on the fluorine on the left side, and they only belong to that fluorine, and we call them again lone pairs. So a way to draw the shared electron, which is the preferred way in chemistry, is to do a covalent bond. A covalent bond is a dash. Every dash means two shared electrons. Every dash is a covalent bond, and it means single covalent bond, and it means two shared electrons. So a single bond, its atoms share one pair of electrons. Double bond, the atoms will share two pairs of electrons, and that usually happens between carbons, oxygen, nitrogen, sulfur, and phosphorus. Here is an example. This is carbon dioxide. Carbon dioxide share these orange electrons here. These two pairs of electrons are shared between the oxygen and the carbon. Okay, and the oxygen on the right, and the other 4 electrons here are shared between the carbon and the oxygen on the left. That means there are 2 covalent bonds between carbon and the oxygen on the right, and 2 covalent bonds between carbon and the oxygen on the left. Each oxygen will still have its own lone pairs, right? Now, oxygen has 8 electrons, carbon has 8 electrons, and the other oxygen has 8 electrons, and the carbon has 8 electrons. Triple bonds that can also happen between carbon and nitrogen, I'm going to have 3 pairs of electrons shared, like the 2 nitrogen in the nitrogen molecule here. So this here is what we call the nitrogen molecule. It's a triple bond because we have 3 pairs of electrons shared. So every nitrogen can have 8 electrons, or the octet, fulfilled. Now, some covalent bonds are polar, and that means there is an even distribution of electron density. What does that mean? It's caused by the difference in electronegativity. Yes, atoms share electrons, but that doesn't mean that sharing is even or 50-50, right? Some electrons are stronger in some atoms are stronger in pulling electrons toward them. We learned that when we learned about electronegativity. We said that electronegativity is the ability of the atom to pull electrons stronger to it in a covalent bond. Fluorine, for example, is the most electronegative atom, meaning it will not be shared 50-50 with another atom if it happened to be a hydrogen, for example, right? It will be way closer to fluorine. Here is an example. The bond between hydrogen and fluorine express a shared pair of electrons. However, these electrons are way closer to fluorine, and we can look at that with something called the electronic map. And in the electronic map, the red part will show us where we have a high electron density, and the blue part is where we have like deficiency of electrons or poor electron density. Now, if I want to visualize that, if there are 2 electrons that are shared between fluorine and hydrogen, they are not in the middle. They are rather very close to the fluorine than they are to the hydrogen. Now, hydrogen does share them because hydrogen will pretend to have 2 and look like helium, and if fluorine does share them and will have the octet. But in the bond, those electrons are way closer to the fluorine than they are to hydrogen. So fluorine represents the electron-rich region in the molecule, and hydrogen will represent the electron-poor region in the molecule. Therefore, we say that fluorine has a partial negative charge, and hydrogen will have a partial positive charge. So what does that mean? It means that if fluorine managed to steal that electron completely, gain it in a different word from hydrogen, then that will put a -1 charge on it, and it will leave hydrogen with a +1 charge. However, fluorine was not able to completely gain it. It's still sharing it. So it will gain a charge. It will not be -1. It will be partial, maybe -0.7 or -0.5. It depends, right? Hydrogen will not completely lose that electron. It's still shared, but it got far away from hydrogen. So hydrogen is not +1. It's rather positive 0.4 or something like that. That's what we mean by partial negative and partial positive charges. That also make the bond, we represent the bond as having a dipole. And a dipole is drawn on the same axis as the bond. Arrows are heading to where electrons are going. So arrow will be heading towards the more electronegative atom. And the tail will have a plus charge, or the plus part here to indicate the presence of a partial positive. So when I draw a covalent bond, I can draw the dipole. The dipole is going towards the fluorine, and that is the part that will be partial positive, which is the hydrogen end. Here is a table that shows me the electronegativity of different atoms. It's worth noting that fluorine is the most electronegative atom on the periodic table. Non-metal are definitely more electronegative than metals because they tend to want more electrons, right? Now, you do need to know relative electronegativity between the atom, and I have a way to make you memorize it. If you write fun Funkel bricks paha. Cool. Funkel bricks paha, right? So this here tells me that fluorine is more electronegative than oxygen. Oxygen is more electronegative than nitrogen. Now, nitrogen and chlorine is they are the same, right? So these are the same, and then bromine less electronegative than chlorine. Iodine is less electronegative than bromine. Carbon and iodine are the same. Then sulfur is less electronegative than sorry, I made a mistake here. Carbon and sulfur are the same, and then you have phosphorus and hydrogen are the same. Okay, so the way I made myself remember that, it's like Funkel, comma, bricks, paha. So the last two elements of every part are the same. Funkel, chlorine, nitrogen are the same. Bricks, sulfur, carbon are the same. Paha, hydrogen and phosphorus are the same. Funkel, bricks, paha. Okay, and this is, if you remember that, that will always allow you to know the relative electronegativity between different atoms. Here you go. So this is another way you can remember it. Now, comparing polar bonds, we look at the electronegativity difference between the two atoms that are making the bond. If the electronegativity difference is large, which means one of them is way more electronegative than the other, that will polarize the bond and will make one end of it to be rich in electrons and the other end to be poor in electron. If there is no electronegativity difference between them, then this is a 50-50 shared, and that will be non-polar at all. And there are also something in the middle. So let's have a look here. The fluorine-fluorine covalent bond, of course, the electronegativity difference will be 0 because similar atoms, similar electronegative value, and therefore that will be a nonpolar covalent bond. Carbon-nitrogen, the electronegativity difference is 0.5, and that's a small difference, but it's enough to call it polar because the nitrogen end will be more electron rich because nitrogen is more electronegativity than carbon. So that's a polar covalent bond. Hydrogen fluorine has a high difference, and that will make it also polar covalent bond. So what's the difference between these two? One of them is more polar than the other. They are both polar, but one of them is more polar than the other. Now, when the electronegativity difference is very large, like higher than, I think, 2.1, then now at that point there is no sharing at all. All what's happening right now is ionic, right? The electronegativity difference is so large that fluorine is not interested in sharing anymore. It is so powerful it can steal that electron altogether, and lithium will.